You may have heard it said that we eat one credit card's worth of plastic every day. Fortunately, that has been debunked, but it doesn't mean that the plastic that we are consuming or ingesting is not affecting us. When we're talking about nanoplastics, we're talking about something that's between 1 nanometer and 1 micrometer, which is to say between a billionth of a meter and a millionth of a meter. So in this length scale, you have things like DNA at the low end and viruses. So this is really small. The point is that this is kind of the scale of a lot of biologically active components in your body. Before we get any further, I want to introduce my main source for this video. This is a paper by Joseph Burdock from Murdoch University, and it's called Microplastics and Nanoplastics: Fate, Transport, and Governance from Agricultural Soil to Food Webs and Humans. Before we get into all that though, I really just want to address the question of why should we care? So what? It's just plastic. What's the big deal? Well, the thing is, we're not really sure. There is a lot of preliminary research showing the effect of microplastics on health, but a lot of it is not definitive yet. Unfortunately, there's enough there to start making people very, very concerned. In particular, this review article points out that there's been research in several major areas of concern: neurodegenerative issues, cardiovascular impacts, especially with an increased risk of heart attack and death, endocrine disruption, which is to say the sort of hormones and signaling going throughout your body, and reproductive effects. So that should be enough to get us worried. But even if this is not nailed down science yet, I really think that you need to think in terms of where should the burden of proof be? Should the burden of proof be for us to prove beyond a shadow of a doubt that micro and nanoplastics accumulating in our bloodstream and in different parts of our body is harmful? Or is the burden of proof on the purveyors of nanoplastics and microplastics to prove that it's not harmful? To get more specific, here is a concept I found particularly upsetting. In this study, patients with carotid artery plaque in which MNPs were detected had a higher risk of a composite of myocardial infarction, stroke, or death from any cause at 34 months of follow-up than those in whom micro or nanoparticles were not detected. So that's a quote. To me, when I saw this micrograph, it just gave me a visceral reaction. You can see in this picture, so this is transmission electron microscopy, and you can see from the scale bar that we're talking about features which are around 1 micron or smaller. And this is pictures of macrophages, which is to say kind of part of like the cleanup duty of your body, part of your immune system. You can see that there are these jagged, irregularly shaped particles accumulating inside macrophages and then also present outside of macrophages. These are basically found in analysis of erythromatous plaque, which is, according to the article, a fatty substance that builds up in your arteries over time. So this is basically like the plaque in your body that can build up in your arteries, which is responsible for cardiovascular events. But it's just so striking to see you have now not only like the regular stuff like the saturated fats and cholesterols and things like that might be a concern, but now we're accumulating these jagged little log jams of plastic in our arteries. It's just very concerning to me. So, maybe this is fine, right? I'm reminded of the meme with, I think it's like the dog in the burning building where he said, this is fine. But the reality is this stuff is showing up in people's bloodstreams. And whether it's the cause of mortality or if it's just there as part of it, I'm not sure, but it's very concerning. Okay, so let's get back into how these things wind up in our bodies in the first place. And this paper is going to put a really strong emphasis on ideas like farming practices, which was kind of a surprise to me, as well as some of the more obvious sources like litter. The first big source that the paper talked about, which was a surprise to me, is an agricultural method called plastic mulching. Plastic mulching is an incredibly innovative and effective way to boost crop yields. But as you can imagine from the video that I'm showing here, is that bringing this much plastic into contact with soil, combined with the wear and tear surrounding installation, removal, and just sitting out in the wind and the weather, just gives ample opportunity for plastic particles to wear away and enter the soil. A review from 2023 found that 39% of soil-focused studies identified plastic mulch as the primary source of microplastic contamination. Another surprising and disappointing entry point is actually sewage that's used for farming practices. Now, the sewage is typically processed to prevent the spread of infectious diseases, but this is a really profoundly good use of resources because it's really rich stuff, the processed sewage coming from wastewater treatment plants. This is a bummer to me that this is a source of microplastics because apparently the processing techniques used to turn sewage into fertilizer material for farms is really good at removing certain kinds of hazards, but it doesn't do much to remove microplastics and nanoplastics. And this is really interesting to me. So for whatever reason, the biosolids, which is derived from sewage, has different amounts of plastic in it. Now, I don't know, how is all the plastic getting into the sewage? Is it because people are dropping, plastic components into the sewage stream and it ends up getting processed? Or is it from, perhaps we've heard like certain shampoos contain microplastics, and then this is the thing that like really kind of disturbs me, or is it because people are, excreting plastic into their toilets and then that's winding back up into the environment? I'm not sure. It's probably a combination of these things. But the article goes on to say that the concentration of microplastics in biosolids differs across different nations. And so different nations seem to have a different kind of concentration of plastics in the sewage. It's between 0.7 microparticles per gram in the Netherlands to 240 microparticles per gram in China on a dry weight basis. Oh, here's my cat. Oh, she's very interested. Anyway, once these materials are in the farming soil, they're going to wind up in the plants that we eat, the vegetables and the crops that we consume, through different mechanisms. Now, the exact mechanism of how the plastics wind up in the plants does differ based on the type of plant and the type of microplastic. I'm not going to go into depth here, but you can see that there's been quite a lot of research done into exactly these mechanisms. And there are different ways that it happens. In some cases, they're incorporated through what's called endocytosis, or there's foliar uptake, transpirational pull. So the idea is that with that one is that as water is evaporating from the leaves, that's creating kind of a capillary action, which is pulling up more water and nutrients from the soil, but you're also going to potentially bring the micro and nanoplastics up into the plant as well. This, of course, translates into having microplastics in our food. The article talks about a study by Oliveri-Conti et al., which investigated the abundance of microplastics and nanoplastics in 6 commonly consumed fruits and vegetables. In this study, apples and pears contain the highest concentration of microparticles. The concentration of microparticles range between 52,050 and 233,000 particles per gram. The authors attributed higher microplastic concentrations in fruits to higher vascularization, size, and age than in vegetables. They reported an estimated daily intake of microplastic particles from apples reaching an astonishing 462,000 particles for adults and 1.4 million particles per kilogram for children. Maybe that's because kids eat a lot of apples, I'm not really sure. Another study focused on contamination of 16 protein-based products, including seafood, meat, and vegan proteins. It noted that the product MP level averaged 74 particles per serving, particles varying from around 2 in chicken breast, which doesn't seem bad, to 370 in crusted shrimp. Now, the shrimp thing is interesting because obviously shrimp being raised in the ocean, they're getting their plastics from a different source than the ones we've been talking about. And that's most likely due essentially to flotsam and jetsam that gets into the water over time and breaks down into microparticles and then is accumulated by different living things in the ocean. Now, how worried should we be about this? From my perspective, it's hard to tell. The reality seems to be that plastics have made their way into our body and into our blood, and we just can't escape eating more and more of them. I'm sure that the vast majority of these pass harmlessly through and probably we just, pass it back into the sewage system and then it gets recirculated back into farming. But it increasingly looks like it's not a completely innocuous thing. The authors of this review paper make a really strong case that we should be making a much bigger deal about this than we have up to this point. They say the widespread presence of MPs and NPs and plastic additives in food highlights an urgent and unmonitored health hazard. They go on to say, the plastic waste iceberg will continue to expand beneath the surface, largely unseen, until its full impact is impossible to ignore. So how can we fix this? Now, these are just a couple of ideas from me, a random guy on YouTube, but I think that we should be looking into changing how we do farming. I know that's a bit rich for me to say. You know, I benefit from our complex and highly productive farming system every day that I go to the grocery store and I'm able to afford groceries. Because of that, I don't want to seem ungrateful at all to our farmers, but I do think that we're going to have to take a serious look at how we handle microplastics and nanoplastics in our farming system. Another area that people are working on right now, and I think we need to continue to work on, are personal care products. So it was not too long ago, I remember, that I started to hear about efforts to get less plastic in our shampoos and our soaps and our cosmetics. The reason why this is important is that when you're done with shampoo, it goes down the drain. And once it goes down to the drain, it winds up in the sewage system. And once it's in the sewage system, of course, then it has a chance to wind up eventually in our food again. The third thing is awareness. I think if more people are just thinking about this, then eventually more minds working on the project will hopefully yield more results. And then finally, we may need eventually more laws to deal with this. If in fact this is correct and this is becoming a slow-moving public health disaster, then eventually we're going to need to really rethink the way we do things on a system-level basis. Now, if you have other ideas on how to fix this problem, I am all ears. I'd love to hear what you have to say. I feel like I've barely scratched the surface on this topic, and there's a lot that we don't know yet. I haven't even addressed how microplastics can get into your body through things like erosion from plastic pipes, water bottles, plastic food containers, plastic wrapping in grocery stores, inhalation, IV tubes used during medical treatment, through skin contact from sunscreen, cosmetics, and more. But does it matter? It looks like it matters at least a little bit. How much? Only time and a lot more research are going to tell us. I want to end this on a hopeful note, though. I think that humans have a decent track record, that once we all agree that we have a problem, we have a pretty good track record of fixing certain things. There are certain diseases which are now extinct. A number of years ago, you may recall that there was a big problem with the hole in the ozone layer, which was caused by, I believe it was chlorofluorocarbons, that's right, CFCs, which were causing a hole in the ozone layer, which was going to increase the amount of degradation of the atmosphere and increase the rates of skin cancer. Fortunately, there was a solution. The Montreal Protocol was an international agreement signed in 1987, which phased out these ozone-depleting substances. As a result, the ozone layer has been gradually recovering, and scientists predict a full recovery to pre-1980 levels by around 2066. Overall, the health hazards of microplastics and nanoplastics are just beginning to be understood. I think this problem might get a lot worse before it starts to get better. And it's certainly more widespread or ubiquitous than I ever dreamed before I read this article. That said, I don't think we should panic, but we should take this very seriously. This is not an innocent until proven guilty thing, or it shouldn't be treated as such. Remember, the burden of proof is on nanoplastics and microplastics to prove that they aren't harmful, rather than the other way around. In the meantime, I think it behooves us to pay more attention to this and try to find ways to make small changes in our daily lives and just be aware of the potential of microplastic contamination in our diets. I hope you found this video to be interesting or useful in some way, and if you did, please go ahead and like and subscribe, and I hope to see you here again soon. Bye.